Hi, everyone. Today we're going to start talking about our next unit, which is right triangle trigonometry. So this word trigonometry, what it is it's just a branch of math that uses right triangles to find the measure of something that cannot be measured directly. So examples, things like the height of a mountain, the height of the stars. What it does is it makes a ratio of the lengths of two sides of a right triangle to an angle of the triangle. So the first thing we have to be able to do is we have to be able to name the sides of our triangle. If we can name the sides, this is going to be one of the easiest things you've ever done. The hypotenuse is always the longest side, and it is always across from the right angle. So remember, if I have a right triangle, right here is my hypotenuse, always. Now, the other two sides, we're going to call the other two sides legs, but we have to be more specific. So the legs are going to change depending on where the angle that we're talking about is. So we either have what we call the adjacent, and remember adjacent means next to, and the opposite side. Now, depending on the kind of triangle we're given, right, is going to depend on what we call the adjacent side and what we call the opposite side. Now, the opposite side is across from the acute angle. So if I have a right triangle, and let's say this is my acute angle right here, if I want the opposite side, I want it way over here. That's way there on the opposite. Now, the adjacent side means that it is next to the acute angle. So, if I have a right triangle, and let's say this is now my special angle, this side right here is my adjacent. Over here, this would be my adjacent, again, next to. Way over there would be my opposite. Okay, so just think opposite, way on the other side. So what I want you to do is I want you to determine the hypotenuse first. Okay, so if I want to determine my hypotenuse, I find my right angle, across from my right angle, there's my hypotenuse. Now, here is my reference angle. Okay, so I'm looking for the side that is next to it. So this is next to, so this is my adjacent side. And then therefore CB has to be way on the opposite side. If I take a look at the next one, okay, again, I identify my right angle. Always from the right angle is my hypotenuse. And if Q is my reference angle, right, notice that P has nothing on it, P's blank, then this is my adjacent. And this side over here is my opposite. So there's three functions that we're going to use in trigonometry. And if you take a look at your calculator, you'll see those three things right on there: sine, cosine, and tangent. So I know that it says sin, cos, and tan, but sine, cosine, and tangent. And those three buttons right here, right? Sine, right? Sine. Notice how it opens up something. Right? So that's your hint there, that there has to be something in the middle. All right? So whenever we say we have the sine of, and this x is always representing an angle. X is representing an angle. Tangent is an angle. So we have sine, S-I-N-E, of x. And the way we're going to write that, the ratio is the opposite side over the hypotenuse. Our cosine of an angle is our adjacent side over our hypotenuse. And our tangent function, all right, so I'm sorry, cosine, this is tangent. Our tangent is our opposite side over our adjacent side. Right? So we use this acronym here, SOHCAHTOA. Now, SOHCAHTOA just reminds you what are the sides that you're using in your ratios for sine, cosine, and tangent. Some people like to write it as SOHCAHTOA as well. Some people like to think about this like a little rhyme, like Oscar had a heap of apples. And then notice OH, AH, OA. And again, they're always going to go in that order, sine, cosine, tangent. And your calculator does the same thing, so it's easy to remember. So if I'm given this triangle ABC, I want to write a ratio for each of these expressions. So the first thing that I want to do is I want to identify where my right angle is. So C being my right angle, AB is always going to be my hypotenuse. Now, what's also helpful is to help let's write SOHCAHTOA right on the top of our paper here. And what we're going to do is we're going to write a ratio for each expression. Okay, so I'm going to start with A. So if A is my angle of reference, I want to know what side is opposite from A. Well, this is opposite, and this is adjacent. So my opposite side would be BC. My hypotenuse is still AB, so that's my opposite over my hypotenuse. My cosine would be my adjacent, which would be AC over my hypotenuse, AB. And my tangent, being my opposite over my adjacent, I'd have BC over AC. Now, if I am going to talk now about angle B, so what I want to do is I want to go back and I want to change this now. Because if I'm not talking about A anymore, right now I want to talk about B. Now B being my reference angle. Now this side is my opposite, and this side is my adjacent. So my sine of B, my opposite side, I have AC over my hypotenuse AB. My cosine of B, my adjacent side, would be BC over AB. And my tangent, my opposite over my adjacent, I have AC over BC. Now I do want you to take a look for just a moment at the connection here, right? Where I have that is actually the same as that one. That one's actually the same as that one. So sine and cosine are co-functions. And then notice these two, the way that they're opposites from each other. All right, so back before people had calculators readily available to them, they would use this thing called a trig table. So this table here would be something that you'd have in the back of a book maybe that would tell you what the ratio was of the sides given the actual degree measure that we have. So what I would do to use a trig table, right, is I would take a look. So typically I only know one of my angles. Okay, so if I only know that this is my angle here, I only want to find, let's say it's like the, that should be it. Let's make that 12 over there. Let's say we want to find the height of this opposite side, and I know the length of this hypotenuse. So maybe I know the length of a guy wire, and I'm looking for the height of a tree. So what I have is I have my opposite side. I have my hypotenuse. That's O and H. So I know that I'm going to be using the sine function. So the sine of 54 degrees equals my opposite over my hypotenuse. So now what I could do is I could take a look over at my trig table, and I could find sine of 54. I could find sine of 54. And I could also think about this. I mean, I have a calculator now. I put in sine of 54. Oh, not 44. 54. And notice, my calculator's in the wrong mode. Silly me. I need to make sure my mode is in degree. I was going to talk about that later. I need to brew it now. So now notice if I do sine of 54 again, notice I get that number. All right, we do need to be in degrees. We'll talk about what radians means in a moment, a couple lessons actually. But make sure your mode is in degree mode. All right, so I can either use my calculator value, right? I can cross multiply here. So x is actually equal to sine of 54 times that 12. So I'd have 12 times 0.8090. And I can put that into a calculator and get an answer for that. All right, so let's take a look at a problem that we have here where we have some numbers. So the first thing I want to do is I need to find the length of ED. So I have a triangle. I have two sides of it, and I'm looking for my third side of my right triangle. So the first thing I want to do is I want to use my Pythagorean theorem, and I want to find the length of my third side. So 5 squared and 12 squared. So there's 25. Oops, plus. Plus 144. That's 169. So now I know that ED is 13. Right, take square root of the whole sides. All right, so there's 13. So if I'm looking for the sine of E, okay, so again, helpful to write SOHCAHTOA right there on your page. So I'm looking for my opposite over my hypotenuse. So if E is here, my opposite, 12 over 13. My cosine then of E, my adjacent, so 5 over 13. My tangent of E, right? My tangent, so I have my opposite, I have my adjacent, so I'd have 12 over 5. Now, if I'm talking about D, now if D is my angle, now all of a sudden this is my opposite and this is my adjacent. So my cosine of D, my adjacent side, is now 12. Oh, I'm sorry. The opposite side. Silly me. My opposite side of D is 5 over 13. My cosine of D, then my adjacent over my hypotenuse, there's my 12 over 13. And my tangent of D, my opposite over my adjacent, is going to give me 5 over 12. Now, if I want to find the answer to E, what I'm going to do is I'm going to go into my calculator, and I could do something like second sine 12 divided by 13. Okay, so in the calculator, second sine 12 over 13. And there we go. It's about 67.4 degrees or so. Now, this will work for any one of those ratios. It doesn't have to just be for sine. So if I wanted to go back and I wanted to look at cosine of E is 5 over 13. So I want you to think about this like you are undoing the function. So I need to get rid of these. I need to break them apart. So second cosine 5 over 13. Okay, so second cosine 5 over 13. And again, I get the same exact angle because again, I was finding that same ratio. All right, if I want to find D. Okay, so we said about 67.4 degrees. All right, so if I wanted sine of D, right, I could get rid of sine. So I need to do second sine 5 over 13. Okay, so in my calculator, second sine 5 over 13, I get about 22.6. Well, isn't that what that should have been anyway? Right? So this plus a 90-degree angle, right, all together has to be 180 degrees. All right, so there's 3 things you're going to do to solve a trig problem. Okay, so this is the good stuff. This is how we're going to solve these problems. So the first thing you're going to do is you're going to label the triangle with what's given to you. So if 70 is my reference angle, I have right here an adjacent side. I have over here an opposite side. So if I think about SOHCAHTOA, I've identified that I have an A, I have an O. That means I'm going to use my tangent function. So tangent of 70 equals my opposite side over my adjacent side. So now all I want to do is I want to cross multiply. So think about this like it's all connected over 1. So I'd have x equals 8 times the tangent of 70. Go to my calculator. 8 times the tangent of 70. And it said round my answer to the nearest integer. So this is about 22. So x is, we'll say approximately 22. All right, let's take a look at the next one. So here's my angle. So right here, I have my adjacent side. I have my hypotenuse. So if I have an A, I have an H, I use my cosine. So cosine of 60 equals my adjacent over my hypotenuse. Okay, so again, I'm going to cross multiply. And this time when I cross multiply, though, I have 30 equals x times the cosine of 60. Well, that doesn't help me get rid of that. So let's divide both sides by the cosine of 60. Cross that out. Now I have 30 divided by the cosine of 60. Oh, I get 60. So my x equals 60. All right. Now, the only other thing that happens, the third thing that's going to happen is you're looking for the angle. Now, notice that this one's different, right, because we're looking for an angle. So, same idea, though. I'm going to look over here. I have an opposite side. I'm going to look over here. I have a hypotenuse. I think about my SOHCAHTOA. Opposite and hypotenuse is telling me I'm going to use my sine function. So I have sine of x equals my opposite over my hypotenuse. Now this is the only one that's going to be a little bit different because in the calculator, I use the second sine function. So go to my calculator. Second sine, the inverse of sine, equals 3 over 6. Oh, 30 degrees. 30 degrees is my answer. So x equals 30 degrees. And again, this one I'm finding an angle measure rather than the length of a side.